Hello, grade 8 learner. Welcome to another video lesson in mathematics. In this video lesson, we will be discussing how to graph a linear inequality into variables. This lesson is based on the K-12 curriculum learning competency. The learner graphs linear inequalities into variables. By the end of this lesson, you, the learner, should be able to follow the steps in graphing linear inequalities into variables. It's another great day to learn, so prepare your module, pen, and paper as you start watching and learning from this video lesson. Happy learning! Let's review how the graph of a linear inequality looks like. The graph of a linear inequality in two variables is similar to the graph of a linear equation except for two things. The line that is used, which is either solid or broken depending on the inequality symbol used, and a shaded region that describes the solution set of the inequality. Refer to exercise 2, item number 1 of your module for this example. Let's graph the linear inequality 3x plus 4y is greater than 12. Let's observe the inequality that we are going to graph. Note that the inequality symbol used is greater than. Let us process what we know. To graph the linear inequality, we must first know its x and y intercepts. We also know that the inequality symbol used in the inequality is greater than. Lastly, we have to determine the half plane that must be shaded to describe the solution set of the inequality. To graph the inequality, we need to solve for its intercepts. We begin with the x-intercept. We first turn the inequality into an equation. Then, to solve for the x-intercept, the value of y is set at 0. This results to the expression 3x is equal to 12. To solve for x, we divide both sides by 3. Doing that will result to x is equal to 4. This means that the x-intercept is at 4, 0. Let's solve for the y-intercept. We turn the inequality into an equation first. Then, we set the value of x to 0 in our equation. This gives us the expression 4y is equal to 12. To solve for y, we divide both sides by 4, which results to y is equal to 3. This means that the y-intercept is at 0, 3. Let's plot the intercepts we have solved for. From our solutions, we saw that the x-intercept is at 4, 0, while the y-intercept is at 0, 3. To know what line we are going to use in the graph, we look at the inequality symbol that is used in the inequality. We see that it's greater than, so the line that we are going to use is a broken line. Let us check which region is going to be shaded in the graph. Is it this region or is it this region? We choose 2, 4, and -1, 1 as our test points from each region. Let us test 2, 4. We begin by writing the given inequality. Then, we substitute 2 and 4 to x and y in the inequality. Simplifying the expression, we multiply 3 and 2 to get 6 and 4 and 4 to get 16. We add these two products to compare it with 12. As a result, we check if 22 is greater than 12. We know that this statement is true. Therefore, we conclude that 2, 4 is a solution of the inequality. To test negative 1, 1, we begin with the inequality. We substitute negative 1 and 1 to x and y in the inequality. Simplifying the expression by multiplying 3 and negative 1 and 4 and 1, we get a result which is 1 is greater than 12. We know that this is a false statement. Therefore, we conclude that negative 1, 1 is not a solution of the inequality. From what we solved, we saw that 2, 4 is a solution of the inequality, while negative 1, 1 is not. Therefore, we shade the half plane where 2, 4 is to describe the solution set of the inequality. Let us state the conclusion of our problem. The following graph is the graph of the linear inequality 3x plus 4y is greater than 12. And this ends our video lesson. I hope that you have learned something new today because, to quote the American businessman Malcolm Forbes, the main purpose of education is to replace an empty mind with an open one. Keep on learning, dear learner, and we'll see you again in our next video lesson.